OCI, Orange County Inspections, is glad to present the following. The Quality Control and Quality Assurance Professional Seminar, segment number 15. Within this segment, we will cover the AISC, American Institute of Steel Construction Manual. AISC is a non-profit organization which was founded in 1921 and is based out of Chicago, Illinois, which provides technical and trade specifics for the fabricated steel industry. The first topic will be the dimensions and properties for structural products commonly used in steel buildings and construction. Next topic is the specifications for structural steel buildings, which was developed as a document to provide uniform practices in the design, fabrication, and erection of steel frame buildings. And last topic is the specifications for structural joints using ASTM A325 or A490 bolts, which covers the design, installation, and testing of the bolted assembly. First topic is the dimensions and properties, which covers items such as the general design consideration, design of both flexural and compressive members, design of tension members, design of members subject to combined loading, design consideration for bolts and welds, and the design for connecting elements. Now we take a closer look at the structural products, which will cover the W, M, S, and HP shapes, channels, angles, structural tees, hollow structural sections, pipe, double angles, double channels, W shapes with cap channels, plate products, raised pattern floor plates, and crane rails. We start with the table that covers the W-shaped members, and we'll focus on this part. First, you see the table callout, which encompasses the W-shaped members. Next, you will see how this image works hand in hand with these table columns. First column covers the member size. Next column gives the area of the member being used. You notice the letter D, which stands for the actual depth of the member. Now we look at this column, which covers the web, and here is the symbol. Plus, here is the column that reveals the web thickness. We move to the flange column, and we have two different symbols that reveal both the width of the member and the thickness. A quick tip is, this column will alert you if UT testing is required. Because remember, the AWS D1.1 requires any plate 5/16 of an inch or thicker using a groove weld to be tested. And the last column is the information provided for the distance of the member. Now we'll become familiar with the different shapes covered in this manual. So we start with the four types of I or H beams that are very common throughout the steel industry. First shape was the W, which we just saw, and now you are seeing the M shape. Next is the S shape, which is known as the American Standard Beam. And the last beam shape is the HP shape, also known as the bearing pile. We now see the two types of channels. First is the C shape, and next is the MC shape, or also known as miscellaneous channel. Now we move into the angle shape, or also known as the L shape, which could have legs of equal or unequal lengths, but usually the same thickness. Here are two of the three structural T shapes, which the first is the WT, and then the ST. We bring an often misunderstood abbreviation to you, which is HSS, which stands for hollow structural sections. And there are three shapes, with the rectangular being the first. Second is the square. And lastly is the round. We come to the table for pipe. First, the table provides a category chart that provides columns for the pipe diameters and schedules, but please notice the three different tables provided. The first covers a pipe for standard weight, then extra strong, and lastly double extra strong. So, as you review the mill certification of what you might think is a common piece of pipe, slow down and make sure it matches what you really have on the floor. Okay, we have the double angle shape necks, which are just two separate L angles connected back to back. We now see the double channels, or also known as 2C shape. Here is the raised pattern floor plates, which is part of the plate product section of this manual. And lastly are the W and S shapes with cap channels. Now, with each shape, the channel web is connected to either the W or S shape's top flange. The second item of dimensions and property is a handy table that simplifies the various types of structural fasteners used within the industry. And that is Table 2-5, which breaks down the different available ASTM designations as we see here. Next is the fastener material strength. Now we see the diameter ranges for that designation. Okay, we want you to focus on this area, which will make the table easier to understand. Plus these three legend items down here, which has a dark colored box that stands for the preferred material to be used, a gray colored box that stands for material that must be confirmed prior to being used, and lastly a white color box that stands for not being able to be used at all. Now let's review the different fasteners that are provided within this table. First are the high strength bolts covering the conventional and twist off type. Second are common bolts and nuts. Third are washers, both the common washer and direct tension indicators. Fourth are threaded rods. Fifth are shear stud connectors. And lastly are the anchor rods, which have either a hook, headed, or threads plus nut for an end. And of course, with any table, we will always be looking for the footnotes, which are provided here again at the bottom. Okay, we see the different areas and parts to this table. Now let's run through a few scenarios. First example, what is an A307 fastener? So we find it on the designation column, then look for dark colored box, which reveal it's a common bolt, but also notice how it could be used for an anchor rod with a hooked end. Second example, what material can be used for shear studs? First, find a column that covers shear stud fasteners. Then look for the dark colored box, which reveals the designation of A108. The last item of dimensions and properties is Table 14-2, which covers the maximum hole size in a base plate plus washer information. Here we see the table and it looks simple enough. But notice how there is two sections for the different sizes provided. Next, we cover each column provided, and the first is the actual rod dimensions being used, which covers 3/4 of an inch up to 1.5 inch rod diameters. Second column is the actual maximum hole allowed in the base plate column. Third column is the minimum washer dimensions allowed. And lastly is the minimum washer thickness allowed. Here we see the same columns for the groupings of diameters that cover sizes 1.5 inch up to 2.5 inches. And of course, what would any table or chart be without slowing down and locating the footnotes provided? We now enter the second topic of the segment, which will cover the specifications for structural steel buildings, which was drafted using past success and increased knowledge from the design experiences of steel frame buildings. First item is the general provisions, which recap the specifications, code, and standard documents that provide industry requirements for the use of material and practice for the design, fabrication, and erection of structural steel buildings that induce both vertical and lateral resisting forces. The specification begins with material that must conform to the ASTM standards. Second comes a key definition, which is built up heavy shapes. That means any material thicker than 2 inches. The specification moves into drawings, being consistent with the Code of Standard Practices of Steel Buildings and Bridges. And the following points are provided: stability analysis and design, design of members for tension and compression, plus flexural, shear, and torsion, while lastly covering the design of composite members. Second item is the design of connections, covering both the simple connection of beams, girders, or trusses that are required to be designed as flexible and can react to shear only, plus designed for the rotation of beam ends, and also covering moment connections of restrained beams, girders, and trusses that are designed for both moment and forces from actions within the rigid connection. Other items covered are compressive members within bearing joints, think columns, splices for heavy sections, beam copes and weld access holes, weld and bolt placement requirements, connection limitations using groove and fillet welds. The following is also provided for bolts and threaded parts: high strength, size and holes, spacing and edge distance, bearing and slip critical connections, connecting elements such as fillers, splices, anchor rods, while concluding with the design of HSS, hollow structural sections. And the last item is the fabrication, erection, and quality control for the shop. A quick tip is, both the shop and erection drawings shall clearly state the difference between shop and field welds, plus the pre-tensioned and slip-critical bolt connections. We first enter into the item fabrication, which covers camber, curving, straightening, thermal cutting, edge work, finishing work, holes, and galvanized members. This leads us into the painting within the shop for inaccessible, contact, finished, and adjacent surfaces. Next is the erection, with items like the alignment, bracing, field welding, and painting. And we finish with the quality control, which is provided by the fabricator that assures the work is in accordance with the specifications, plus at any time the material and workmanship can be observed by the representative of the purchaser. The last topic of the segment is the specifications for structural joints using ASTM A325 or A490 bolts, which gives the strength requirements of the slip critical connection, a modification for round-headed A490 bolts, and simplifies the use of plate or hardened washers, to just mention a few items. Once again, we review the general requirements, which start with the drawings, in which the engineer of record must specify the ASTM designation and joint type. Next is the storage of heavy hex structural bolts, nuts, and washers, including washer type indicators and twist-off tension control. Then we move into the bolted parts, which cover the plies, fang surfaces, holes for standard, oversized, short, and long slots. An important section provided is the joint type, which covers the snug tighten, pre-tensioned, and slip critical, which leads us into the washer use section, which covers beveled, slotted, and direct tension indicator. And lastly is the verification for pre-installation that provides the calibration and testing procedures for a tension calibrator. The second item of this topic is the installation, which covers snug tightened, pre-tensioned, turn of the nut, calibrated wrench, twist off, and direct tension indicator methods that require the following variables to be verified: the bolt and nut thread finish and tolerance, lubricant evenness, degree, and condition, condition of shop or field site, the bearing area of the bolt and nut faces, parameters for the air supply of impact wrenches, plus their conditions, lubricant, and power supply, and not to forget the repeatability of performance. And the last item of this segment is the inspection, which, when required by contract documents, ensures the work in progress meets this specification. The following joints are covered: snug tighten, which must be visually ensured that all plies in the assembly have been brought into firm contact. Next is the pre-tension, which requires observation when turn of the nut, calibrated wrench, twist-off type tension control bolt, or direct tension indicator methods are used. And a quick tip is, the fang surface of a slip critical joint must be visually verified that there is no scale, coating, or dirt prior to assembly. And we take a look at the meaning of arbitration before closing this segment, which is basically suspicion the joint is not properly tensioned. The following must take place to prove compliance. First, a representative sample of the bolts must be tested in a tension calibrator, also known as a Skidmore. Second, a manual torque wrench shall be applied to 10% or a minimum of 2 bolts within the questioned connection. Now, if no bolts turn under the arbitration testing, the joint is accepted. But if any bolts do turn, the entire connection must be tested. We have come to the end of segment number 15, and let's review the topics we covered. First, we started with dimensions and properties. This section was established in 1927, and with this seminar, we reviewed the 13th revision of this section that involves structural products such as member shapes, visual appearance of the tables covering the LRFD and ASD design methods, while also looking at new information dealing with items like pipe, analysis and stability requirements, corrosion protection, and charge for plate girders. Next, we looked at the specifications for buildings, which is the broadest AISC publication to date, with the basic provisions being to determine the available and nominal strength of the members and connections of the steel building structure. Many of these structures are found in the petrochemical plants, power plants, and both private and public sectors that use the design, fabrication, and erection of this provision. And lastly was the specification for bolts, where we cover the basic principle of the 2 strength grades for high strength bolts, being ASTM A325 and A490, plus the design, installation, and observation of these bolts in the structural steel joints. Next were the different assemblies like the twist-off type tension control and how this specification relates to the fastener's performance in a structural steel joint. The study material for this segment will cover the following. First is the Steel Tube Institute's article on hollow structural sections. Second is the Historical Structural Steel Working Handbook written by W. Bates. Next is a document covering structural steel high-strength bolt installation and inspection procedures established by the Raytheon Polar Service Company. And lastly, the Turn-Assure Corporation Instruction Manual for installing high-strength bolts with direct tension indicators. If any questions arise, email orangecountyinspections@yahoo.com. When completed, move on to segment number 16.